take a baby marshmallow and place it in a syringe and cover the open end with a finger. According to Boyle's law, when volume decreases, pressure increases. This is shown because when we move the plunger down, the volume then is decreased, and this causes a pressure increase, which makes the marshmallow shrink in size.
Cause it's 9 in the afternoon, and your eyes are the size of the moon. You're good cause you can, so you do.
First, we taped a piece of string to a ping pong ball. We turned on the faucet and held it by the moving water. The ball is attracted to the moving water because according to Bernoulli's principle, a moving fluid has a lower pressure. The higher pressured air pushes the ball towards the lower pressured moving fluid since pressure travels from high to low.
We took ivory soap, which is less dense than other soaps because it is pumped with air. We put it in the microwave for about 2 minutes. The soap gets bigger because as the temperature increases, the volume of the air in the soap increases, causing it to get bigger. This is an example of Charles' law.
So you do. We're feeling so good, just the way that we do when it's 9 in the afternoon.
We drew an arrow on a piece of paper and then placed it behind an empty glass cup. When we pour the water in, light bends or refracts the image in the water, making it appear flipped. This is an example of refraction.
We took a laser pointer and shined it through a tiny slit in a piece of paper. This is an example of diffraction because you can see the different wavelengths when it shines through.
We take two identical glasses and fill them with the same amount of water and place them next to each other. We rubbed our finger around the rim of one glass. The sound waves travel to the other glass, causing the glass to vibrate. This is an example of resonance. We took a metal spoon and attached identical pieces of wax. We then heated the spoon on the end away from the wax. The pieces start to melt off, starting with the closest one to the flame. This happens because the molecules in the spoon start to move around when heated, transferring the energy down the spoon towards the wax. This happens because of conduction. This experiment required us to make a sphere of tinsel and levitate it with a negatively charged balloon. This would have happened because the mylar tinsel would have repelled the negative charges in the balloon, causing it to float because it was light enough. However, we could not find the right tinsel, so when we negatively charged the balloon, the tinsel was polarized and stuck to the balloon instead. We marked a spot on the axle and the wheel and rotated each of them once. The wheel traveled farther. When using an axle and a wheel, you only have to turn the axle a small distance to move the wheel a bigger distance, but it requires more force.
Newton's first law states that an object at rest will stay at rest and an object in motion will stay in motion as long as the forces are equilibrium. The forces on the chair are at equilibrium until I pushed on it.
Newton's second law is force equals mass times acceleration. The objects hit the ground at the same time, even though they have a different mass and force. They accelerate at the same speed, though, due to gravity. According to Newton's third law, when the books are thrown at Heather, the force from the books causes her to move backward because she has an inverse force.
Okay. It sticks. I hear it. Apparently the goal is for it to float without floating.
I'm so sad.
Can we look up where to buy my lock?
I guess this. Ah! I didn't mean that!
Wait, you have to put it in first. You have to open it. You have to push the button to open it. Okay. Yeah, good. Okay. Okay, go. No, that didn't go anywhere.